211, so let's get started. Introduction. So the purpose of Lab 4 was to analyze the motion of a mass oscillating on a spring and compare the experimental and GlowScript model's motion. The main physics principles used in Lab 4 were the energy principle, the momentum principle, the velocity and position update formulas, and the spring force and gravitational force. The end result is that the x and y position graphs of the coded model were very similar in shape with the model positions, but slightly deviating from the experimental model. Energy change in the system is conserved and equals 0, and we found that using the GlowScript model as well. So here is my tracker it's more of like the experimental values that I found here. Pretty self-explanatory. Now, the initial conditions in the GlowScript were found. So the ball's mass was 0.402 kilograms, which is found in the video lecture. The initial position was found in tracker at t equals 0. The ball's initial velocity was 0 because it started from rest. The spring constant was found right here using the equation k equals 4 pi squared m over the period squared. And the relaxed length here was found using the equation the force gravity equals the force of the spring. Now, systems and surroundings. So the system for the forces is the ball or mass, and the surroundings is the spring and the earth, as those are acting upon the ball or mass. Now for energy, the system is the ball, earth, and spring, and that makes it easy because no external work is done outside the system, so there is no surroundings, and therefore, in the next slide for the energy principle, we can see that in this equation, delta E, it equals 0 because there's no work in the surroundings. So, in this lab, we had 3 energies of the system comprising of delta E. We had the kinetic energy, gravitational potential energy, and the spring potential energy, all which will be found in GlowScript later. Now, in order to find the x and y positions in GlowScript, I had to find the force net, because the momentum principle states that a mass changes motion when exposed to a net force. So in order to find velocity final, the motion, I had to find the net force first. So I found the net force with force gravity plus force spring, and that I plugged into the velocity update formula, and then from there I found the velocity final and plugged it into position update formula. And there I found the positions. So here's the energy principle in GlowScript with all of the energies right here, such as k equals 1/2 mv squared, potential energy for the gravity equals mgh, and so on. And that equals the delta E value right here. And so position update formula in GlowScript and velocity update formula in GlowScript can be found right here, with the force net being the spring plus gravity, and that is plugged into the equations right there. So the lab results. So in the x position graph, we can see that there's a difference in position, and that increases with time. So the increment, the difference in the positions for the model and experiment increased with time, and this is because that the spring constant was found using the period t for the first 3 oscillations of the experimental values. Thus, the variation gets bigger with time. And in the y position, the min and max values are different for the 2 curves, which could signify that there was slight air resistance or other work done in the experiment to cause it to deviate from the coded model. Now, the what does it mean part 1 asks us if the energy principle is satisfied in this experiment. And the answer is yes, because the energy principle is delta E equals the work surroundings. The work surroundings is 0. Therefore, in our graph, we can see that delta E is 0 throughout the experiment, meaning that energy is conserved, which satisfies the energy principle. Now in part 2, it's asking us to find 2 separate estimates of the oscillation periods, one for x and one for y, which I found right here using the 3 oscillation periods and 3 oscillation periods for the x and y. Now, the different periods for x and y, which were found back there, could have potentially thrown off my GlowScript model. Our k constant was found using the period for y, so using it to find the x position could make slight deviations in my GlowScript model compared to the experimental. Using the average of these 2 periods could help lower inaccuracies in our coded model. So some possible sources of error in my experiment were plotting the points in tracker inconsistently, some not on the center of mass, some on the center of mass, and the air resistance was not accounted for in our calculations in GlowScript, but they are existent in real life. Thank you.